A question regarding DC motor. Now, a circular loop of wire has a diameter of 20 centimeters and contains 10 loops. The current in each loop is 3 amps, and the coil is in a 2 Tesla external magnetic field. What is the minimum and maximum torque exerted on the coil? So working through this, what we've got is the minimum torque will occur when theta is equal to 90 degrees. This is because when sine of 90 is equal to 0, that will give us 0 torque, 0 Newton meters. And when we remember our diagrams for a DC motor, when it was at a vertical position and it was in a point that was actually not connected to those brushes and those strips of wire, those little coil parts, there was no force acting upon it. And it was just continuing to spin when it was in that position. So that's our minimum point of torque. Our maximum torque will occur when theta is equal to 0. That gives us that sine of 0 is equal to 1. So our equation for the torque is going to be equal to N, the number of coils, the current, the area, and inside a magnetic field. Sine theta is going to be equal to 1, so I'm just going to leave that out. So now we're going to figure out the area. We know that we have a diameter of 20 centimeters. So that means that it's going to be circular, and we're going to have a pi r squared area. So that's going to be pi times 10 squared, and that's going to be our area. So now we can just plug in our values into it. We get number of coils, or the number of loops, is 10. So 10 times the current flowing through, which is 3 amps, times the area, which is pi times 10 squared, times by the external magnetic field, which is 2 Tesla. That gives us 1.88 Newton meters worth of torque.